Down under. In today's session, we've got the transaction log and how it affects HA and DR by Edwin Sarmiento. Now I'll hand over to Edwin shortly. For those of you who don't know me, my name is Warwick Rudd, and I'm going to be your host for today's session. Before I hand over to Edwin, I've just got a couple of little things to run through from a housekeeping point of view. And so just going to do a short plug for our upcoming SQL Saturdays in the Down Under area. So in Australia, in May, we've got a SQL Saturday event in Brisbane, and in April we've got an event over in Christchurch. Now, like we did last year in Brisbane, we are running some pre-con events, and if you are interested in those two pre-con events on the 27th, feel free to go to the Eventbrite site. The details are, as you can see, on the link. Now, for next month, the session is already up and available for you to register, and we will have Tim Radney from SQL Skills talking about the common SQL Server mistakes. So with that, I'll now hand over to Edwin so that we can start the presentation.
Totally forgot the fact that my phone's on, or my microphone's on mute. Good morning, good afternoon, or good morning in your case. It's actually night on my end. Give me a quick second here while I flip over to my demo environment real quick and show you my slide deck. I just need to make sure that everything is up and running for everyone's benefit. Show my screen. There we are. All right. I hope nobody chastises me for using a Mac. Good morning. How is my slide looking like?
It looks good, Edwin.
All right. Perfect. That's always great to hear. Quick second over here. There we are. And I hope I get this whole presentation done in an hour or less. I promise to keep it under an hour. It's one of my favorite topics. My name is Edwin Sarmiento. I'm a SQL Server Microsoft Certified Master and a data platform MVP. I blog on a regular basis. In fact, I would strongly recommend, and I'd like to invite you guys to subscribe to my newsletter. I send out emails and information about SQL Server and anything related to SQL Server high availability and disaster recovery. So feel free to check out my blog, my email address right over there. You can also follow me on Twitter or connect with me on LinkedIn. Like I said, this is one of my favorite topics on top of failover clustering and availability groups and all of that. But the main reason why I like this topic is because of the fact that every high availability and disaster recovery solution that you would choose to implement will hinge on how transaction log works. In fact, I should have entitled this with something like, you know, SQL Server Transaction Log internals. But that's a bit of a stretch if you look at it, because most people don't really pay attention to how SQL Server Transaction Log really works. But when you start thinking about how it impacts every decision that you will make and how transaction log will end up affecting your database backups, your log shipping, replication, availability groups, failover clustering, and everything else, then it starts to make a lot more sense. And like I said, I'd like to start off with how transaction log works and how you know, the internals and how it impacts SQL Server and every other every other high availability and disaster recovery solution that you're going to be choosing. So imagine this: whenever you're sending transactions to your SQL Server database, whether it's an insert, update, or delete, your data definition, data manipulation languages, all of those transactions are logged. Now, you could think of it in terms of, well, as a user or somebody who's running transactions against SQL Server database, imagine this happening within your database. Imagine you're sending a statement like update something or update a table, set column equal to column value. What SQL Server does is it first looks at whether or not the corresponding record or the corresponding page for that record that you're trying to update is already in memory. If it is, that change will be applied to the in-memory copy of that data. Now, a lot of when we started off with, in my case, this is something that I thought happened when I changed something in the database. This was back in the days when I was still starting off as a student of SQL Server. That I thought, hey, when I run a transaction, I thought it's going to change the data directly in the MDF or the NDF or all of the data files. But actually, that's not what happens. What happens is that SQL Server first writes those changes into the transaction log. This is the principle called the write-ahead logging in SQL Server. And just about any relational database management system has this particular concept where the changes that you make are written in the transaction log. Now, depending on how your database is configured, whether it's in simple recovery model, full recovery model, the behavior is quite different in terms of how the SQL Server keeps those log records, but it first has to write those changes into the transaction log file. And at regular intervals, the checkpoint process runs. By default, it's 60 seconds, and those changes are written from the transaction log and into the data file, your MDF, your NDF files, or wherever those pages are stored on your SQL Server database. Keeping in mind, though, and it's one thing that I wanted to highlight, is the fact that unlike the data files, where you got random file access patterns, when you're inserting records, you could randomly write and read records in your data file, it's not quite the same as the log or transaction log file. Transaction log file is accessed, read and write, in a sequential file access pattern. And the reason I highlight this is because I'm going to show you later how SQL Server then looks at the transaction log, then reads it and writes to it in a sequential file access pattern. Now, all database changes are written in the log, whether users are responsible for making those changes, like your DML statements, your DDL statements. Those are user-initiated transactions. But on top of the user-initiated transactions are transactions that the database engine need to write or implement in order to make everything consistent. This may appear in terms of, hey, when you defragment your index, because your indexes are a bit fragmented. When you defragment your index, SQL Server has to keep track of all of the changes that have to be made in order to defragment those indexes. When you have to create a new table, and the table has to be mapped to a certain file in your database, that is considered a transaction, and SQL Server has to keep track of that. So whether it's user-initiated or system-initiated changes, everything is written in the log. And this allows for point-in-time recoverability. Now, you might be thinking about full recovery model and point-in-time recoverability, but I'd like to think of point-in-time recoverability in terms of how SQL Server can read, in case something happens, from the transaction log at specific point in time, which is very much consistent to the ACID property of any relational database management system, which allows for consistency in which case. Because SQL Server has to first write those changes in log, those changes need to be read from the log or records from the log to check whether or not they're consistent. And of course, because they're written in the log first, they're made durable in the log file. Now, the log gets full over time. Users interact with the database, they submit transactions to the database, and the transaction log gets full. Imagine that you've got and I'm just going to use numbers in this case for illustration purposes. Imagine that you create a 512 megabyte sized log file for your 8 gigabyte sized database, for example. Even though you're seeing just one file in your file system, one 512 size or 512 megabyte size LDF file. Within the LDF file, SQL Server will subdivide that transaction log file into what I call subsections or subdivisions. These subdivisions are called virtual log files or VLFs. Now, inside those virtual log files are smaller subdivisions called log blocks. These log blocks are a way to group the log records that are written into the SQL Server Transaction Log file. And those log blocks, or rather those log records will contain those changes that the database engine has to make for user-initiated transactions or system-initiated transactions. Now, how does SQL Server track the log records? SQL Server tracks log records through the log sequence number, and I kind of think of a log sequence number as the unique identifier of every record in the SQL Server Transaction Log. You kind of think of it as the index in the SQL Server Transaction Log record. You know, when you have records, or when you're inserting records in a table, for example, and you want to maintain uniqueness for those records, what you do is create an index or a primary key, depending on how you want to look at it: physical index, logical primary key. But in this case, the log sequence number is used so that SQL Server can identify uniqueness for those particular log records. Excuse me. And I'm just going to create a series of transactions, color-coded transactions in this case, to illustrate the purpose. Keep in mind, in a client-server application, in a multi-threaded, multi-user application, there's a certain amount of, well, depending on how much resources you have on your database, you can have as many transactions as possible on your database system. So for illustration purposes, let's just use 4 users executing transactions individually, and I've color-coded them. User 1 sends transaction 1 with the gray color. User 2 sends transaction 2 with red color, and so on and so on. And again, because of the sequential nature of the log, let's say transaction number 1 initiated an insert into the database. It's doing bulk insert within a transaction. And transaction number 2, for example, is also inserting records into the database. Now, keep in mind, there is no guarantee that transaction number 1's log records will be written within a single VLF or within a single log block. Again, because of the very nature of a database system where you got potentially lots and lots of users who could insert records into the database, there will be simultaneous log records written into the log file as well. So if you look at it this way, you know, transaction number 2 could be interspersed within transaction number 1. And maybe transaction number 1 is a long-running transaction, which is why you're seeing transaction number 1 occupying virtual log files number 1 and 2, whereas transaction number 2 is only in virtual log file number 1. You got to think of it that way. And because of the fact that the log is sequentially accessed, that's how the transactions are written into the transaction log. And why did I highlight the fact that it's sequentially accessed? Well, if SQL Server has to roll back transaction number 4, it has to look at the blue records in reverse. This one first, and then this one, and then this one, and then this one. And the same thing with all the other transactions that are in the log file by reading the log records. Now, they're everywhere. You can look at log sequence numbers, and you can find them everywhere, whether it's on your transaction log file, your database backups, your data pages. In fact, if you crack open a SQL Server data page and you read the data page using the dbcc page, dbcc command, you would see a log sequence number corresponds to when that particular page was verified in terms of how SQL Server checks for consistency. So they're everywhere, and that's how SQL Server references the log records using the log sequence number. And when you start breaking down the log sequence number, you'll see it in the form of the log sequence number, the block number, and the record number. And when you combine, of course, you might be thinking, how can SQL Server really keep track of that? Well, the values are in hexadecimal values, but then you got tons and tons and tons of log records getting written into the database, and so SQL Server has to uniquely identify them. So a combination of the VLF sequence number, and I'm going to show you that later in the demo, log block number, and the log record number. Now, as I mentioned earlier, these smaller subdivisions are called virtual log files, and the minute that you create a log file, rather a transaction log file in your database, the very first virtual log file is always marked active. In fact, there will always be one virtual log file marked active for every SQL Server transaction log file. Now, the last three virtual log files, the white ones, these three, let's say nothing is going on at the moment and it's currently empty or inactive. The first log record written to a virtual log file will make it active. And why am I even highlighting that? The fact is, as we move forward and start talking about the sizes of these subdivisions, even a very small size transaction will make that virtual log file active. So how many virtual log files will be created per log file? You kind of think of it in terms of this particular formula where you've got the number and the size of the virtual log files inside your transaction log file or your LDF file. Like I said, even though you're looking at a 512 megabyte sized LDF file on your file system, inside consists of virtual log files with corresponding numbers, corresponding sizes. So let's take a look at this formula, for example. If you have a log file that is 64 megabyte or less, SQL Server will create 4 new virtual log files at the quarter of the size, whether you're creating a log file for the first time or auto growth kicking in and adding into the existing size of the transaction log file. So let's use this particular example to illustrate the point. Let's say you created a database and you specified that the log file is about 8 megabytes, roughly. So, or rather, 32 megabytes rather. So SQL Server will create a transaction log file of size 32 megabytes, and inside we'll have 4 virtual log files at 8 megabytes each. And we're going to look at that later in the demo. For anything between 64 megabytes and 1 gigabyte, SQL Server will create 8 new virtual log files at 1/8 the size. So again, using numeric values to illustrate the point, if I have a database with 800 megabyte sized log file, SQL Server will create that 800 megabyte size LDF file with 8 virtual log files at roughly 100 megabytes. Roughly. And I'm saying roughly because you'll see later that it's really not exact, but it's how the formula determines the size of those virtual log files. Now, what about anything above 1 gigabyte? Now, this is where SQL Server will start creating 16 new virtual log files at 1/16 of the size. So for example, you create a database with an LDF file of 16 gigabyte sized file. So SQL Server will create like 16 virtual log files, each at 1 gigabyte. Now there's a lot of change, well, not really a lot of change, but there's something that was introduced in SQL Server 2014, and I said later because, well, SQL Server 2016 is just right around the corner. SQL Server 2014 has a new algorithm in terms of how virtual log files are sized and created. And I've taken this from Paul Randall's blog and SQL Skills. So it looks at the growth size in terms of the actual size, which means if you're looking at, if you're looking at percentage growth, the growth or the auto growth size will be different every time it kicks in, because 10% of 1 is 0.1, but 10% of 1.1 is no longer 0.1, and it keeps changing. So the formula here is that it creates one new virtual log file equal to the growth size, which becomes a bit more challenging, especially when you're trying to monitor the virtual log file numbers. But if the growth or the size is not less than 1/8 of the current log size, then it will still use the formula that we talked about earlier. Now, moving forward, the log file will get full over time as you start writing records into it. Question is, what happens if the transaction log file gets full? In fact, this question is something that I ask in some of my presentations, and depending on the crowd that I'm presenting this information into, I get 2 different results. Those who are not hardcore SQL Server professionals would say, well, it'll autograph. But for those hardcore SQL Server folks who understand how transaction log works, this is their common response. Well, the first thing the SQL Server does is it checks for an inactive portion of the log. It just checks. And what it does is it looks at the virtual log files inside log file being sequentially accessed. Here's what SQL Server will do. It will circle back to write on that portion. So say, for example, that very first virtual log file is marked inactive. It will go back to that and start writing on it. Now let's say the first portion is not inactive, but the second one is. It will write on the second one, but skip the first one. This is one of the things that a lot of SQL Server professionals are not made aware of, because of the fact that SQL Server can only write into a virtual log file if it is marked inactive, and which is why I mentioned earlier, the very first record written in a virtual log file will make it active. Now think of it this way. Let's review some of the concepts that we talked about and the size of the virtual log file. If your virtual log file is 1 GB, because of the formula that we had, if it is 1 GB, even if it only takes 32K to write a log record, it will make that virtual log file active. So even if you have to truncate the log, and we'll talk about that later, even if you have to truncate the log, but there's just 1 log record, 32K log record, cannot be truncated, the whole virtual log file will be marked active and cannot be overwritten. Now, when does a virtual log file get marked as inactive? And I know I jumped ahead of myself and talked about this. A virtual log file becomes inactive when all log records in it are no longer needed. And this is where I start talking about, some of the different high availability and disaster recovery solutions that you have within SQL Server. Say, for example, a log backup. This log backup is one of your disaster recovery solutions. Well, a backup is replication, availability groups, database mirroring. These factor into whether or not a virtual log file becomes inactive. And later, like I said, later on we'll talk about that. Now, this process is called clearing the virtual log file, or truncating the virtual log file, and eventually truncating the log, which is a bit of a misnomer, because in reality it's really not erasing the contents of the virtual log files. All SQL Server does is flipping the switch. Hey, this virtual log file is, all of the log records in here are no longer needed. Let's just flip a switch and mark it inactive. And when SQL Server sees that as an inactive, that the only time that it clears and erases the records in the log file is when it will start writing into it. Like I said, which is why this phrase is a bit of a misnomer when you think of clearing or truncating, because when you think about the term truncating, you think, well, SQL Server is really erasing it, but in reality, it isn't. Now, what causes the log to get truncated or to be cleared? There's only two reasons for the transaction log file to be cleared. First one, log backup. This is if your database is in either full recovery model or bulk log recovery model. Now, one thing to keep in mind, just because you're running a log backup doesn't guarantee that your transaction log file will get truncated. Let me repeat that. Just because you're running a log backup doesn't necessarily guarantee that you'll get your log file truncated, because at the end of the day, if there are records in that particular virtual log file, SQL Server will not be able to clear the virtual log file even if you run a log backup. Again, I'll explain that in more detail later on. Now, if your database is in simple recovery model, then a checkpoint process will be responsible for truncating the log. And again, similar in concept, just because the checkpoint process is running doesn't necessarily guarantee that the log file will get truncated. As long as there is something in those virtual log files that are making them active, even a single log record, as I mentioned earlier, even a 32 KB sized log record that is keeping that virtual log file active, SQL Server will not be able to clear or truncate the log. Now let's continue. Now, if there are no inactive portions of the log, this is where it starts growing. Of course, we're assuming that autogrowth is enabled or configured. By default, it is. But in some cases, you might not consider auto-growing your database files. Now, this is a bit tricky, especially if it's a highly transactional database and your transaction log file grows on a regular basis, which is why, by default, auto-growth is always configured. Transaction log file grows, virtual log files get full, SQL Server can't find inactive portions of the log, it auto-grows and grows. So let's take a look at a very simple demo on looking at transaction log and understanding the circular nature of the logs. Let me log into my, oops, not this. Let me log into my demo environment here, and hopefully you can see my screen. Perfect. So what I'm going to do is I'm just going to create a very simple database, and I am just setting the database with, and I want you to pay attention to the size, 5 megabytes, auto growth 1 megabyte. So if we go back to our formula on the size of the log file and the virtual log files created inside a log file, we'll see later how that factors in. Of course, I don't have a, let me just create a demos folder here, new folder, demos, and just want to make sure that the users, okay. Now all I'm doing here is just creating a folder for my database. Create a database, and I'm just going to set the database to a simple recovery model, and the only reason for that, and of course, let me set simple recovery model and auto create statistics to off, just so it does not generate other transaction log records. Now let me use the command dbcc log info to illustrate some of these things. Keep in mind that we created a database with a log file of 5 megabytes. Going back to our formula, it's less than 64 meg, so SQL Server will create 4 virtual log files at a quarter of the size of the log file. Look at the file size, 1.25, 1.25, 1.25, 1.5, something. So I have 4 virtual log files, each at 1.25 roughly at a size. Okay. Looking at the sequential nature of the log, F sequence number is a column that will tell us the sequence of how SQL Server has written into the log. The value of 0 simply tells us that SQL Server has not used this particular virtual log file just yet. So if I start adding records in my table, in my database, transactions generated, if SQL Server starts using this particular virtual log file, F sequence number for this will be 35, 36, 37. Again, understanding the fact that SQL Server Transaction Log files are accessed sequentially. Status column. Status value of 2 means it's active. Status value of 0 means inactive. Status value of 1 is I don't know what it is. And based on some of the information I know from the product team, nobody knows. Parity. Parity is flips between 64 and 128. It just tells SQL Server whether or not this particular virtual log file has been reused after it has been rewritten. Again, keep in mind the sequential nature of the log, whether it's read or write. Let's create a table and introduce some transactions in the database. I'm just going to insert records into this particular database. Inserting 400 records. Let's look at the log file again. And we start to see values, which used to be 0 initially. Now it's 35, 36, 37. And as I mentioned, just looking at the F sequence number column will show us the sequential nature of the log. 34, 35, 36, 37. A bit of a tidbit. 34. Why 34? Because this is the F sequence number in the model database. So you can take a look at your model database and take a look at the current F sequence number of the model's log file. Status of 2, which means all of these are now marked active. I don't know how many seconds have gone past since I ran DBCC log info, but by default the checkpoint process runs every 60 seconds or every minute. And so probably in a couple more seconds, if I run DBCC log info again, these three will be marked inactive because the checkpoint process already ran. 64, which means SQL Server has not overwritten these yet. So let me validate. Okay, so it's not truncating the log yet because every single record is still useful. Now here's what we're going to do. Let me create a transaction, or let me open an open transaction. Same thing. And I'm just going to use that, but I'm not going to be committing the transaction. I'll keep the transaction open. Oops, wrong window. Let me copy this over. DBCC log info. Same thing. Now let's repeat the exact same. Let's repeat the exact same thing as what we did earlier. Just want to remind myself that the open transactions are over here. And we'll insert records into the database. Once that's done, we'll run and look at DBCC log info again. Now you might be thinking, how come this is not completing? Well, I've got an open transaction here, so it's probably it's taking quite a while to complete. Now look at what happened here. Look at what happened here. Status of 0 means this particular virtual log file is marked inactive. So we started off with 34, 34, 35, 36, 37, 38, 39, 40, 41. SQL Server decided to auto-grow. Now I want you to pay attention to these 4 virtual log files. Notice the size, 25 something, approximately 250K, because if you remember, our auto-growth increment was set to 1 megabyte. Therefore, 1/4 of 1 megabyte is 250K, 250, 250, 250, roughly 250. It's not the same as the original size of the virtual log file because of the fact that the auto-growth increment is different from the initial size of the log file. And it affects not just the file creation process, but also the auto-growth process. Now let's continue. Sequential nature of the log, 36, 37, 38, 39, 40, 41, 42. SQL Server went back to the first virtual log file, checks, hey, do I have some virtual log files that are marked inactive? Again, it's a side effect of the checkpoint process because the database is in simple recovery model. Found these 2 to be marked inactive, reused them. So from 41, 42. Notice the parity value has changed from 64 to 128. Now, this is SQL Server knowing that this was reused and overwritten, making the status active. 42, 43, but still 36, 37, 38, 39, 40, 41 is still there. And of course, until this particular transaction is committed, 36, 37, this particular virtual log file contains that active transaction. In fact, let's do that one more time and see how things would go. And let's insert more records and see how SQL Server will look at the inactive. Notice that we have one inactive portion in the log that SQL Server can write into. 42, 43, 44. What used to be 36, which was inactive, is now marked active. But look, 37, 38, 39, 40, 41. Remember this active transaction that we have? This active transaction is still in this particular virtual log file. And if you look closely, 41, 45, SQL Server cannot reuse all of these virtual log files because they're marked active. And so what SQL Server had to do was to auto-grow, skip these 44, 45, 46, 47, 48, 49, 50. And these 2 are marked inactive. Well, SQL Server has to auto-grow based on the number or the size of the auto-growth increment and the number of virtual log files added based on the formula. Until we commit this particular transaction, let's just do that. Let's commit that. Until the transaction is committed, SQL Server will not be able to reuse these up to here. Now, as a side effect of that is if your database continues to let the transaction log file auto-grow, all of these transactions will go back to this particular transaction or this virtual log file to look at that open transaction, which means the transaction log file has to hold a series of pointers back to this. because if you decide, or if I decide to run a rollback transaction, SQL Server has to know how to roll back all of those transactions for consistency's sake, which means it has to read back 50, 49, 48, 47, 46, 45, 44, 43, 42, 41, 40, 39, 38, 37. That's, again, the sequential nature of the transaction log, whether it's reading forward or reading back. Let's look at the BCC log info again, and until those log records are marked inactive, I hope I've already committed a transaction. Okay, and I hope I don't have anything in here. Let me commit. I'm just not sure if I have it. Okay, so I'm just going to wait until SQL Server would truncate those log files, or maybe a checkpoint. I can't wait for it to run checkpoint, but you know, I'm just impatient. There you go. Status equal to 0. This particular virtual log file is now the only one marked inactive. So if you start inserting records, it will write into these and then circle back into these, which will now be 51, 52, 53, 54, 55, 56, 57, and so on and so on. So that's just how the SQL Server transaction log file works and how the circular nature of the log works. Now, a couple of things to keep in mind. If you have questions, feel free to type those questions in the chat window, or in the questions window, that is. There's also the question window. More than happy to have and entertain those questions as we move forward. Now, you've seen the demo, the circular nature of the log. You've seen how SQL Server goes back, checks for inactive portions of the log, and because it's in a database in simple recovery model, we're relying on the checkpoint process to truncate the log, unless, of course, there is a record in the log that keeps the virtual log file active. And by virtue, every single virtual log file that comes after that cannot get truncated until the very first virtual log file and the very first record that made that log file active is released and is no longer needed. What if it can no longer grow? Well, it can get worse because your database, and I've seen this in a couple of my customers in the past, where the database suddenly becomes read-only. Well, the database property isn't read-only, but it behaves as if the database is in read-only mode because you can no longer insert records into the transaction log file because maybe you ran out of disk space or autogrowth is not configured. Your database, without you knowing, becomes a read-only database without the property being changed into read-only. And I love this particular example because it can throw applications off because sometimes the application was not written to read what really happened in the database. And I think I have a video on YouTube, on my YouTube channel, about how this thing works. And one of the applications that I used was SharePoint. And the error message has nothing to do with SQL Server, but the problem was caused by the transaction log file being full. Anyway, so let's move on and take a look at restore and recovery. This is where SQL Server will restore data from backups, whether it's the entire database, just a data file from partial backups, or a data page or a data page from backup if you decide to restore a corrupted data page. Now, MSDN, TechNet, or SQL Server Books Online will tell you that there are 3 phases of restore. 3 phases. I'd like to point out that there are actually 4 of them. I'm not saying that SQL Server Books Online is incorrect. All I'm saying is there really is, or are 4 phases of restore. The first one is called the file creation and initialization. And think of it this way. When you're restoring a database from backup, the first thing that SQL Server will do is it will have to create the file in the file system. It involves creating and initializing. It's one of the reasons why we recommend instant file initialization for your data files. This needs to happen prior to the data copy phase, where SQL Server will read the backup media and copies the contents of the backup media into the database files that have been created. Now, the last two phases is part of what's considered crash recovery. The redo phase, which applies the log transactions to the data copied from the backup. Think of it this way. All committed transactions will be rolled forward in the redo phase. After the redo phase completes, the undo phase starts. The undo phase is simply rolling back all transactions that have not been committed. Now, the reason I'm highlighting this is because of the fact that you will encounter crash recovery whether or not you're restoring a database backup. What do I mean by that? Well, when you're restarting your SQL Server service, crash recovery would occur, which means SQL Server will look at a transaction log file and checks, are there committed transactions that I need to roll forward, or are there rolled back transactions that I need to roll back? And so this is how crash recovery works. Imagine a transaction that commits before checkpoint. Of course, because it already commits before checkpoint, at checkpoint, SQL Server will have to persist those records on disk or on the data file. Now, if a transaction has gone past checkpoint and the database crashes for whatever reason, SQL Server, upon reading the log file, will look at transaction number 2 and ask the question, was this transaction committed? If it was, it will get rolled forward. Now, transaction number 3, for example, did not complete when the database crashed. When crash recovery runs, SQL Server will roll that transaction back because it was not committed. Transaction 4 gets rolled forward, and similar to transaction number 3, transaction number 5 will get rolled back. Now, what are the different factors affecting recovery time? The amount of records in the transaction log, because of the fact that SQL Server, and you've seen that in the demo as well, the SQL Server will read all of the virtual log files and all the log records in the virtual log files. The more log records in the log file means that SQL Server will have to read more records, which means crash recovery and even restore, crash recovery will take a bit longer. What about the size of the transaction log? Now, keep in mind, only the data files are affected by instant file initialization. The transaction log file isn't, which is why one of the things that I recommend is, well, if you're running log backups, take a look at the size of your transaction log backup and the frequency, and use that to guide you into the appropriate size of your log file. You don't want to grow your log file to about 24 gigabytes when all you have is about 500 megabytes worth of log file every hour. Doesn't make sense, because SQL Server will have to recreate the log file in case, and again, in case you decide to shrink it and then your backups contain a 24 gigabyte log file. The number of virtual log files, and I mentioned this earlier, because of the formula, even a 32K log record will make the virtual log file active. So if SQL Server has to read more virtual log files, SQL Server will have to take more time to read more virtual log files. As a side effect of that, of course, is when there's few of them in a large file means large virtual log files, which means you're wasting space, and therefore SQL Server has to keep track of which virtual log files have been marked active or not. Now let's take a look at the different high availability and disaster recovery solutions available in SQL Server. I will skip past the backup because I'm pretty sure that everyone in here uses backups. If you're not, talk to me. I need to convince you to use backups. Now, let's start off with database mirroring. Now, even though database mirroring has been deprecated as of SQL Server 2012, I still recommend using database mirroring because of cost issues in terms of availability groups in SQL Server 2012 and 14. But database mirroring involves sending streams of active transaction log records to and applying them on the mirror. Let's visualize that and see how it works. But note that SQL Server works in the physical layer, which means SQL Server will read the transaction log records and send those over to the mirror. Here's how it works. When an application sends a transaction to the database file, SQL Server will look at the database and say, do I have database mirroring enabled? If it does, two things happen. Instead of just writing the log record on the LDF file, SQL Server will have to send the same log record on the mirror partner. If it's synchronous, the mirror partner will wait until the same log record gets persisted on the log file on the mirror. When the log record has already been persisted on the mirror will tell the principal, look, I've already persisted the log record on disk. You can go ahead and tell the application the transaction is committed. Now, the application may get a transaction committed message, but if the log record has not been persisted on the mirror, the transaction is not considered committed on the principal because of the fact that SQL Server is working on the physical layer. The beauty of database mirroring is that I should have said mirror, but the mirror is always running the redo process, which means when you try to fail over your principal to your mirror, only the undo phase will get executed. Now, what are different factors affecting failover time? Of course, the amount of log records. The more transaction log records you write on the principal, the more transaction log records have to be sent over to the mirror partner. And when you do a failover, again, crash recovery happening, you don't restart a SQL Server service, it will take some time to run the undo, especially if you got long-running transactions that have been rolled back or need to be rolled back. It will take longer. Now, what about log shipping? Log shipping is simply, and I call it the lazy guys or the lazy DBAs backup, copy, and restore. So you're basically restoring backups of your database into a standby. So think of two databases, and unlike database mirroring, you can have multiple standbys in a log shipping configuration. You have a log backup or backup log job on the primary instance, which backs up the transaction log into a file or a file system that the standby can access. On the standby database server, you have the copy log backup job, which copies the transaction log backup you took from the primary, and then a restore log backup job runs to restore. Now, unlike database mirroring, where only the undo phase runs when you fail over, in this case, you are running, the data copy phase, the redo and the undo phase, because you're completely restoring from backup. So whatever is in the log backup gets restored in the standby database. Of course, keeping in mind that when you implement log shipping, it will break your existing log backup jobs. Now, what are the factors affecting failover time? You might be thinking, why am I just focusing on transaction log? Because, well, that's what the topic of this presentation is all about. The amount of transaction log records, similar to database mirroring, More records mean it will take longer for SQL Server to run the undo. The thing here is, keep in mind that your log shipping databases can be used for read-only, which means SQL Server is really not recovering the database, but it's recording the action of recovering the database, which it's kind of confusing because it's actually using an undo file. So SQL Server recovers the database, but records the process of recovering it in an undo file, so that when you restore the next log backup, it will read the undo file and it will redo the undo, which is kind of confusing, in order for the database to be consistent so that you can apply log backups as part of your log shipping configuration. Now, what about failover clustering? Failover clustering, I'd like to simplify this as simply a group of computers that work together and are accessed as a single system. Now, in a failover cluster, only one server is active at any given point in time, which means when a failover occurs, it's literally restarting the SQL Server service. Let me repeat that. Because only one server in a cluster, one node in a cluster, is currently running the SQL Server service, when a failover happens, it's literally stopping the service and starting it on one of the standby nodes. Now, unlike database mirroring, where only the undo phase runs, in a failover cluster, the whole crash recovery process runs, where it runs the redo and the undo. Now, what are the different factors affecting failover time? Now, again, unlike database mirroring and log shipping, the whole crash recovery process has to run because you're literally restarting the SQL Server service. What about availability groups? And again, this is something that a lot of people are now starting to consider because it's new, it's flashy, although it's expensive. But unlike database mirroring, you can have more than 2 active databases working in an availability group configuration. I like to call this database mirroring running on top of failover clustering. One of the reasons I started off with database mirroring first, even though it's been deprecated, is because of the fact that understanding database mirroring is key to understanding how availability groups work in the context of the transaction log records. So think of it this way. Think of all of these replicas as the database mirroring partner, but instead of just having one partner, you can have multiple partners, and they're running on top of a Windows Server failover cluster. Now, Windows Server failover cluster is responsible for health detection, failover control, failover policies, and all of that. Similar to how database mirroring works is the process of how the log records are copied over to the secondary replicas. And of course, in a database mirroring configuration, you're only concerned with one partner. Here, you can have multiple partners, which means if you have multiple secondary replicas in a synchronous availability group configuration, you are at the mercy, or your primary replica is at the mercy of the slowest secondary replica. And I've told my customers this in the past because primarily they want the production or their primary replica to be, bare metal and have the secondary replica to be virtual machines. And I told them, you certainly don't want to do that because it will impact the performance of your primary replica. But again, because we want to focus on how the transaction log affects recovery, it's the same thing. In a synchronous or asynchronous replica, the primary doesn't have to wait under the secondary replica confirms that the transaction log records have been persisted on disk. And similar to database mirroring, redo is always running in the background, which means if you want to fail over from one primary to a secondary, SQL Server will only have to run the undo phase and not redo and undo. So there's one less process to run, which is why the argument being that availability group is faster to failover in terms of databases compared to failover clustering. And you might be thinking, well, I know exactly what that's going to look like. The amount of log records in the transaction log will definitely affect the failover time. Now, you've probably seen a common theme across database mirroring, log shipping, failover clustering, availability groups as the amount of log records. With replications practically the same, but instead of just using or just replicating the entire transaction log records, SQL Server will pick and choose between the records in the log and only replicate those that have been marked for replication. Because it's originally designed a data distribution strategy, it's not going to replicate everything. It will only replicate, again, the objects that are marked for replication. And this is based on a metaphor of the print publishing industry. Now, the same thing. Let me just wrap up on a context of how it impacts, because SQL Server, unlike database mirroring, log shipping, availability groups, where everything in the transaction log gets replicated, with SQL Server replication, it will have to read the entire transaction log file and check, is this record marked for replication? If it is, I'm going to send it over. If it isn't, it goes to the next one, and the next one, and the next one. Of course, the more transaction log records to work with, the longer it takes to replicate those log files, or those log records rather. Finally, if I have not convinced you yet, this is the one key message and one key theme of this presentation, that your transaction log is the most important part of your database. In fact, I was testing the SQL Server 2016 availability groups with the database level failover. You can lose your data files, maybe have the database or the drive that contains the data files sitting in there and then just completely blown off. But as long as your log files are active and healthy, your transactions are going to continue. And in fact, availability groups will not even fail over to the secondary replica if only your data files get corrupted. It has to be a transaction log on. That's how important the transaction log file is, and as far as I'm concerned, the most important part of your database. Now I promise 1 hour, yay, right on time, 1 hour. So if you have any questions, and I haven't seen any questions in the questions window, but if you have any questions, feel free to ask those questions on a question window. We're more than happy. I'm more than happy to answer those questions. And again, please, there's a lot of resources, a lot of content on my blog. Subscribe to my newsletter, send me an email, post questions on the chat window, or even ping me on Twitter or on LinkedIn. Again, more than happy to answer those questions if you have any.
Thanks, Edwin. Thanks for a fantastic session on the transaction log and how it relates to high availability, disaster recoverability. We actually do have a couple of questions, so I'll run those by you first. So our first question is the DBCC shrink of a log file recommended? How could a log file be kept small even the recovery model is set to full?
Great question, great question, great question. Here's the reality. I work with SharePoint on a regular basis. A lot of the blog posts out there from the SharePoint folks would recommend running DBCC shrink database. I hate it. I hate it. And the only reason I would shrink a log file is when I want to manage a log file. I've seen log files that have grown to 32 gigabytes when the data file is only 512 megabytes. And again, classic example of SharePoint. Nobody thought about running log backups, but because they've got database mirroring or availability groups, they kept the database in full recovery model. Now, as I said, the only reason I use the shrink is when I need to reduce the number of virtual log files. Most people would say 100 virtual log files is less than 100 virtual log files is the recommended one, but again, that is the only time that I would use DBCC shrink, whether it's the log file. I'm not going to use the database DBCC shrink database, but DBCC shrink file specifically for the log file. And it doesn't stop there. I just want to reclaim space to reduce the number of virtual log files, but then I will have to resize it back to the appropriate size. So let's say I've got a 32 gigabyte log file and I'm only using 1% on a regular basis, but I've got, 1,000 plus virtual log files. I'm going to shrink that down to the smallest possible size and then resize it to 512 megabytes. Why? Well, that's probably more than 1% of 32 gigabyte, but I've got more than enough space for me to work around should SQL Server decide to shove in more transaction log records.
Okay, so following on from that one, it goes hand in hand, but so if I'm only running a select statement, is that going to cause the log file to grow?
Great question. My question is, would a select statement cause a change in the database? If it will, then a corresponding log record corresponding log records would be generated, which would cause them to be written to the log. But because the select statements don't actually change anything, they won't.
So we don't need to do anything or worry about it growing.
Not at all.
Okay, so our next question. Do we need to do transactional log backups if we've got always on availability groups configured? And if yes, which node do we undertake those on?
Great question. It's actually a multi-part question. Number one, do you need to take log backups in an I don't even want to use always on in an availability group configuration? Here's the thing: if your database is in full recovery model or in bulk log recovery model, it is recommended to take log backups, because you want to make sure that you manage the size of your transaction log files. That's the reason why you take log backups, apart from the fact that you want to make sure that you can do point-in-time recoverability. Regardless of whether you're using availability groups or not, the only thing to keep in mind is, as long as your database is in full recovery model or bulk log recovery model, you should take log backups. The thing here is, of course, availability groups require full recovery model, which follows that you need to take log backups. Now the next question there is, where do you want to take your log backups? The answer to that is really not something technical. It's more financial. Are you willing to pay for an additional license for your secondary replicas? Because you can take your log backups anywhere. You can take your log backups on your primary replica. You can take it on your secondary replica. The licensing question comes in if you decide to run your log backups on your secondary replicas, because now, well, you have to pay for a license because you're now using them to run your log backups. So it's really a question of how much are you willing to pay.
Okay. Going back to one of your slides, the status field from the DBCC log info with a value of 2. What does it indicate? Is it that the VLF is active or inactive?
Great question. So a value of 2 means the virtual log file is marked active. A value of 0 means the virtual log file is marked inactive. And I could show you that again in here. A status of 0 means it's inactive, and a status of 2 means it's active. And I think my VM just hang there for a bit, but this is what the status column looks like from DBCC log info.
Okay. So what is the default occurrence of the lazy writer, like checkpoint have 60-second interval?
So just want to repeat that question. What is the frequency of the lazy writer, and what is the, so is that, does that have anything to do with?
I think in comparison to the duration or repetitiveness of a checkpoint.
I will have to double check because as you know, I think it was SQL Server 2014. It introduced delayed durabilities, and it could modify some of the default behavior of how SQL Server writes or runs a checkpoint. But I will have to double check on what the frequency is between versions of SQL Server.
Okay. Excuse me. Do you have any suggestions of what the auto growth size should be for a very active production database?
I can't answer that question because I don't know exactly how your production database looks like, but your MSDB database will tell you. Why? Your MSDB database has a copy of your backup history, and I think I have a blog post about that where you can forecast the size of the storage that you need, whether it's for your log file, for your backup, for your database files, by looking at the MSDB database. So look at that. Your transaction log backups will tell you the size between frequencies. So let's say every 2 hours you're running log backups, and your log backup files are roughly about 1 gigabyte to 2 gigabytes, which means your database is capable enough to handle transaction log records between 1 gigabyte to 2 gigabytes every 2 hours. So again, use the backup history information on your MSDB database to come up with a good autogrowth strategy. Now the goal is to to minimize autogrowth, because every time you autogrow your log file, SQL Server has to pause and then autogrow the log file. Now part of that is zero initializing the portion of the log that it has to add on to the existing log file. So the goal is to minimize the autogrowth increment. So based on the history from your MSDB database and the size of your log file, I would probably resize my log file to have more than enough space for the next log backup to truncate. So that way I don't get to autogrowth that frequently.
Okay. So we've got a availability group question. If you have a disk failure on the log file drive in a synchronous commit availability group, are both servers affected? I.e., if a failover occurs, how does the group remain in sync if the log drive has failed on one server?
If the log file on one of the databases in an availability group fails, the entire availability group goes offline, unfortunately. So even if you have your log files on different physical LUNs in your storage subsystem, because of the fact that they're in a group, one database going offline will take the entire group offline. So you might be thinking, so how can you synchronize? Well, the fact that the availability group already went offline, there's not going to be any replication that's going to happen until you bring back the availability group online.
Okay. Which growth options are recommended? Growth by percent or growth by meg?
It's actually a topic of debate between fixed size or percentage. My rule of thumb is answering the question, would you like predictable or unpredictable behavior? Because if you're talking about percentage values, like I said, 10% of 1 will be 0.1. But what is 10% of 1.1? And what is 10% of 1.23? And it keeps changing, which means you will have unpredictable behavior and unpredictable performance. Whereas if you know that you're going to autogrow in 10 megabytes or 100 megabytes increment, you know what to expect whenever autogrowth will kick in. So it's really a matter of predictable versus unpredictable performance, and that's one of the biggest arguments between using megabytes or fixed size versus percentage.
Okay. So the next one is, are you able to share any blogs that explain how the undo and redo process works in an availability group configuration?
It's a great thing you asked that question, because I'm actually starting a series of blog posts about how that thing works in an availability group. Most of the topics that blog topics that I've written in the past were all about failover clustering and just transaction log records. But because availability group is catching up now, that people are now forced to migrate and upgrade to at least SQL Server 2012, it's a great opportunity to start writing writing blog topics about the redo and the undo, and I'll keep that and take note of that. I'll start writing topics about it, but I will definitely forward some information from SQL Server CSS, and there's a blog from the Always On group, the group that's responsible for writing blog posts about SQL Server availability groups. It's worth checking out.
Okay. Now for a bit of a more lighthearted question. So the other questions have been great. Now for a silly one. How about log changes when SQL Server on Linux?
That's a great question. It's a new. Well, I just saw that blog post, an announcement from Scott Guthrie about SQL Server running on Linux. I've been asking for it since, I think, SQL 2000. And the only reason I was asking for that is I used to be an Oracle guy and a Unix guy. So I'm just waiting for the day when SQL Server will be running on my favorite version of Linux. CentOS, that is.
So for the person who asked that question, it's going to be, you'll have to wait and see, because yeah, the announcement was only made this morning. So we'll have to just wait and see what that brings us.
And I'm excited about it.
So why do the log files still continue to grow very large after a daily full backup?
Great question. And I wish I had a demo for that. I think I need to start doing that. I mentioned earlier that a log backup, even a checkpoint in a simple recovery model, will not guarantee that your log backups or your log files will get truncated. And you've seen that earlier in one of my demos. When an active transaction or an open transaction has not been committed, the virtual log file will be marked active. Now, if it is marked active, there's no way that SQL Server can truncate that virtual log file. And what's worse is it becomes the starting point of the sequence of virtual log files that need to be marked active, because the previous virtual log file has to point, or the succeeding needs to point to the previous, and the previous need to point to the previous one, and so on, until a SQL Server can track where that originating virtual log file is in the chain. So even if you take the log backups after log backups after log backups, if there is an open transaction that's preventing the virtual log file to be truncated, then what would SQL Server do is to auto-grow, because it does not have enough space. So the thing that you have to take a look at and monitor on a regular basis is, how much free space do I have in my log file? And you could run the dbcc SQLperf log space command to check on a daily basis. It's one thing that you need to monitor, and you need to look at the trend. Is my log file getting truncated after a log backup?
Okay, so the next question I'll actually answer, because it was, where can we access the recording of this session if it will be available? So in a couple of days' time, the recording of this session will be available for you in the archive section on the DBA Fundamentals website. So if you want to come back and rewatch, just make sure that you go to the DBA Fundamentals website and have a look in the archive section. You'll be able to see not just this session, but all of the other fantastic sessions which have been undertaken. So our next question, how frequently should I take log backups in full recovery mode? Is there a formula? Can that be controlled at different intervals based on transactional activity?
That is a great question. one that I cannot answer for you because, again, I don't know how much transaction you have. And again, one of the reasons why I'm providing a lot of this information is not to answer your question, but to guide you into answering your own questions, because unless I get to see your environment and know exactly what's going on in your database, it's kind of hard to tell. But going back to your question about how frequent, look at what your current log backups tell you. What size are those? Are they enough to truncate the log after 2 hours, after 1 hour? Most people would say, well, we'll just configure the log backups every 15 minutes because that's what log shipping does in the first place. There's 2 rules of thumb that I use when going for log backups. Number 1, recovery objectives. What's my recovery objective? Because that will dictate the frequency of my log backups. Now, the second question that I ask is typically, how much transaction is my production database generating on a certain frequency or on a certain time interval? Because that will dictate, on top of my recovery objective, how often I would run my log backup. Now, you could automate that process by, again, running something like dbcc SQL perf log space and check for, the free space within your SQL Server a log file, and if it hits a certain value and the next log backup won't be until the next hour, you can manually run the log backup job. Again, it's all up to you because you know pretty much how your database works and how much transactions you're getting in a very busy database system.
Okay. Now, this next question, I'm just going to read it out, but then we'll move on to another question, hopefully, to get some further information. So the question is, if we take a backup on the primary, we lose the transactional log sequence. It means we break the availability group. So the person who asked that question, if you're able to provide a little bit more information through so that we can come back and answer that question, that would be appreciated.
I think my understanding of that question is that a full backup causes the log sequence chain to break, and here's the reality of it. Your full backups don't break your log sequence chain. They don't. It's a common misconception, in fact, that people think, hey, how come my full backup truncates my log? It doesn't. Okay. It's really, I would totally recommend taking a look at some of the SQL Server Microsoft Certified Masters video on TechNet and MSDN, and that one of those videos have something to do with how backups work. And again, just responding based on my understanding of the question, you can always send a follow-up to that question. But a transaction log backup is taking note of the log sequence numbers of all the records in that particular backup. But a full backup will take all of the data pages in your database and enough transaction log records to keep the backup consistent, which is, by the way, even if you don't have the latest backup, so long as you have all of your log backups in sequence, you can rebuild your database. So all you need is, the very first full backup and all of the succeeding log backups, and you can, again, bring your database back whenever you need to. It's just not a good practice because, well, how long does it take for you to restore all, 4,000 log backups, if you may? That would blow up your recovery objectives right off the bat.
Okay, so the follow-up, actually, if we pick the primary replica in the AG for transactional backup, then won't it break the availability group for other replicas?
I'm guessing that you have other log backups running, and if you recall, one of my slides there is when you configure log shipping, if you have an existing log backup job, it may look like it's breaking the log sequence, but it's not. It's just that you're not aware of which one was taken. And what I would strongly recommend is for you to, again, I keep referring to the MSDB database because it has all of the backup history, and you could look at all the transaction log backup history to identify, do I have an out-of-band backup, which means maybe it's taken by a third-party backup that's breaking the log sequence chain, making you think that your log backups are causing the log sequence chain just because they're in an availability group. So again, take a look at your MSDB database, review the backup history tables, and take a look at where are these backups stored, because that should give you an idea of whether or not it was part of your regular log backups or maybe a third-party backup, and therefore breaking the log sequence chain.
Okay, so Edwin, if we get a disk full issue, we are taking log backups and deleting after shrinking. Is it effective for DB in case of DR?
So if you have a disk full, here is one thing that you have to remember. A log backup is also a change in the database. Why is it a change in the database? Well, SQL Server has to mark the the log records that have been taken, and in part of that is running a checkpoint, and the checkpoint has to run the log sequence number. If you have a disk full and SQL Server has to write log records in the database as part of the log backup, then you won't be able to run a log backup when your disk is full. A lot of people end up doing a log backup as the first thing that they do when they have a disk full. It's not going to work. And for me, what I end up doing every time I get a disk full and I can't back up the transaction log is, what can I delete in this drive? Or what can I shrink in this drive? What else? Now, it may require some downtime because, well, what database can I move around to free up space? And the goal is to free up space so that you can take log backups. But it's really understanding what your recovery objectives are, because you may have to decide which database to take offline in order to free up some space so that you can do log backups. And again, even taking a database offline, maybe detaching it, will still have to write the log file, which of course is a record that needs to be written, which would prevent you from writing it if again, it's a chicken and egg thing. So you have to really think fast about, are there files in this drive that I could delete that maybe I'm not aware of, or if it's thin provision, maybe I can ask my SAN administrator to allocate more disk space and so on. But again, you have to think really fast about how to respond to that kind of situation.
Okay, so is it true that if we have a database in simple recovery mode and our log file hits 70% full, that a checkpoint happens?
I'm not sure if it's 70 or it's between 70 and 85. I can't remember the exact value, but yes, if it isn't, if it is in simple recovery model, then it does. Okay.
So if the VLF got corrupted, is there any way we can recover them?
Great question. I think I was working with a customer a couple of months back on the same issue, and I can't remember exactly what I did, but because here's the thing: if SQL Server can't read a corrupted log file, your next best bet would be to recover from a backup. So if you have a whether it's a corrupted virtual log file or maybe the header of the transaction log file, as long as SQL Server can't read the transaction log file itself, your best bet is to recover from backups.
All right. So that brings us to the end of today's session. A big thank you to everybody for coming along. A big thank you for Edwin for coming along and presenting to us and staying around and answering your questions. So as I mentioned earlier, this recording will be available in a couple of days' time on the DBA Fundamentals website. The session for next month is open. Make sure that you register, come along, and I look forward to seeing you all in a month's time. Thank you.